For our next example, we're going to use the concept of factorials to demonstrate recursion. And the main purpose of this example is just to show you that a function or a method can call itself in C#. So if I go ahead and run this program first so you can see its results, you'll notice that we're calculating the values of the factorials of 0 through 10. The factorial of 0 is defined to be 1. So that's why we're getting a 1 here. And then for all the other values, we are using the factorial calculation to produce the results that you see on the right side of each equal sign. Now, you can see that main is iterating through the values from 0 through 10. And each time through the loop, we're going to display the counter value, followed by an exclamation point, an equal sign, and then the result of calling factorial with counter as an argument. Now, each of the calls to factorial from line 12 is a non-recursive call. This is the call that initiates the recursion. And then we have the definition of our recursive function here at lines 16 through 24. And you can see I'm not testing for negative numbers. I'm simply assuming that the user will pass in 0 or higher. So if this value is less than or equal to 1, I'm assuming 0 or 1 in that case, then I will simply return 1 as my base case. So you have to have something that's going to terminate the recursion, and the base case is the thing that does that. And if it's not the base case, if I'm not passing in a 0 or a 1, then I need to figure out how to calculate the factorial. And the way you do that is by taking the number that was received as an argument and multiplying it by the factorial of that number minus 1. So if I pass in 5, then the result of line 23 is the value 5 times the factorial of 4. If I pass in 4, the result would be 4 times the factorial of 3. If I pass in 100, it would be 100 times the factorial of 99. And because factorial is a new call to the function, that causes a new function call stack frame to be placed on the function call stack, and that new version is calculating the factorial of 1 less than the original number that was passed in. And then that, if it's not the base case, will cause another call to factorial. And if that's not the base case, it'll cause another call to factorial until eventually we break the problem down to its simplest form, which is the base case. Once we have the base case, then we can return from all of those calls to calculate the final value. So for example, in the context of the factorial of 5, here's a diagram that shows you the sequence of recursive calls and then the values being returned from those calls. So if I start by passing in 5 to the factorial function, the factorial function is going to break that down into 5 times 4 factorial. That will cause a new call to the factorial function. That new call will break the problem statement into 4 times the factorial of 3, which results in a new call to factorial. That new version is going to result in breaking the problem into 3 times the factorial of 2. And again, that's going to cause a new call to factorial, which will break the problem into 2 times 1 factorial. Now, when I pass 1 into the next call to factorial, that's the base case. So at that point, we're now in the return mechanism where we're returning 1 back to the prior call to factorial, which was calculating 2 times 1 factorial. 1 factorial is 1, so I wind up with 2 times 1, giving me the result of 2, which is passed back as the value of 2 factorial. Now I have 3 times 2, which is the value 6, being returned as the value of 3 factorial. Then I have 4 times 6, which is 24, being returned as the value of 4 factorial. And then finally, when we get back here, 5 times 24 gives us 120, and that is the final result for 5 factorial. So the nice thing about recursion is it gives us a way to break down more complex problems into simpler problems until we eventually get to the point of reaching the base case, which allows us to then complete the solution of the problem by returning back through the recursive call chain. Now, this is an example of using recursion just to demonstrate the concept. Factorials are actually more efficiently calculated by simply using a for loop that counts from 1 up to whatever number you're trying to calculate the factorial of, and just multiplying all of those values together. So if I want 5 factorial, it would be easier to just start with a result value of 1 and then multiply it by the numbers from 1 through 5, and that would also calculate 5 factorial in that case.